Yes, good evening all to the another interesting session for the discussion of Routh-Hurwitz criterion. And first of all, I Rakesh Talreja welcome you all to the India's largest online learning platform and to your favorite Grade Up Gate YouTube channel. We are having the startup series for the EC and electrical students, right? And we are having the discussion on the subject of the control systems. And just yesterday, as you know, all know, we had an interesting session. Students were just really enjoying the questions, and we are going to continue that session. That is the Routh-Hurwitz criterion, part number 2. Okay, part number 2. So quickly, first of all, the first thing, quickly share the link of this video to your friends. Spread it along so that we'll have, very good variety of questions today. So quickly share the link of this video. Do like the video. Those who are live, just please like the video quickly. Quickly like the video so that we can proceed with the good positive energy. And just it should be a positive session. Yes, so quickly like the session, share the link to your video, and do subscribe the Grade Up Gate YouTube channel. Okay. Yes. Good evening. Good evening, Satvik, Naresh, Satish, Arun, Ramya Krishna, Zayan, Harsha, Sriram, Atharva, Shiv Prasad, Swarnlata, yes, Natrajan, Kavita, and Ajesh. All of you, very good evening. Diksha, good evening. Okay. Yes. Chaliye, so let us let us continue our session with the discussions on the Routh-Hurwitz criterion. That's the class number 2 today. And as again, this is the brief introduction about me. I'm Rakesh Talreja, and I have secured All India rank 9th in the GATE examination and completed my master's from Indian Institute of Science, Bangalore. The major area of expertise taken by me in my 10 years of journey for the teaching for ESE and GATE is definitely control system, what I'm taking now. And I do take engineering, mathematics, quant, which are the common subjects. And apart from that, electromagnetic theory. Right now I'm taking the CFT also on the electromagnetic theory, signals and systems, and digital electronics. I'm currently running the CFT of the electromagnetic theory. Today I finished up with the topic of the Poynting vector, a very important concept of the Poynting vector. Okay. Chaliye. So class, let's get started with the concept. Let us get started with the concept. Okay, so as you all know, we had discussed about the Routh-Hurwitz analysis, basic cases, okay, and even that case when first element becomes 0. Okay, what all we had done yesterday, I'll just tell you about the basic review of that. What we had done yesterday. Number 1, we had seen the basic questions. Okay, apart from that, we had seen the case of first element of a row is 0. First element of a row equal to 0, the epsilon method, okay, and now we are going to talk about one entire row of the Routh array becoming 0, what happens and what not happens under such cases, how to solve this. Most important case it is, as I've told you. Okay, and then we have seen another concept yesterday, that is about shifting the origin. Okay, how to solve the cases. I've taken the GATE question also, when you are not asking about the location of poles with respect to the j omega axis, but the location of poles with respect to a line parallel to the y-axis, a line parallel to the j omega axis, right? So now the next special case that is coming up in this class number 2, okay, that is one entire row of Routh array becoming 0. Okay, one entire row of the Routh array becoming 0. And to solve such a case, okay, let me just give you the basic required theory. And after going through the theory, obviously question practice is more important, we know. We'll go for the questions. So first of all, as soon as you see a row of 0, what you are going to do? You are going to form the auxiliary equation. That is the step number 1. And how will you form the auxiliary equation? By using the coefficients of equation, which is just above the row of zeros. Okay, whatever is the row of zeros. Okay, differentiate the auxiliary equation. Next step, whatever auxiliary equation you have obtained, differentiate the auxiliary equation to obtain the equation d by ds of as equal to 0. Okay, and then replace the row of zeros. Next is step what? Replace the row of zeros by the coefficients of the above differentiated equation. And then continue the Routh array in the similar manner as you do the calculations of Routh array. So continue that in the similar manner, right? Okay. Now, let us understand this with a basic problem. There are some key points which I need to tell you, but let me take a problem and then I'll tell you what are all the possibilities, what may occur if the row of zeros comes. Okay. What may occur, what are all the possibilities? I'll tell you, I have a list of points, but let us start solving a question first and then talk about those list of points. So a characteristic equation is given to me. Okay, and the same question, like I've not written the complete question like yesterday. What we were doing yesterday, comment on the stability, okay, and determine the number of LHP, RHP and J omega axis roots. Number of LHP, RHP and J omega axis roots. Fine. Chale, so let us get started with this. Let us get started with this calculation. Fine. S power 4 plus S power 5 plus 4S power 4 plus 8S cube plus 8S square plus 7S plus 4 equal to 0. Right, everyone? S power 4 plus 4 S power 5 plus 4S power 4. Yes, good evening, Bhargav. Plus 8S cube plus 8S square plus 7S plus 4. Alternate coefficients. So S power 5, S power 3 and S power 1. S power 4 with S power 2 and then with the constant term 4. I'll start the Raoult array. I will start the Raoult array with these terms. S raised to the power 5. Just understand the one problem together. S raised to the power 5 and then going for S raised to the power 4. First two rows. Coefficients of the first row alternate matter में 187. 1, 8, 7. S power 4. 4, 8, 4. 4, 8, 4. S raised to the power 3. S raised to the power 3. Right. What it is going to be? Yes, Nisha, good evening. So do the cross multiplication. Okay. Like yes, dear students, see, it's a message from the Grade Up team. Do share the link of this video quickly if you have not shared and like the session. So 4 cross 8, as we have learned the Raoult array now. 4 cross 8, 32. 32 minus 8, 24. 24 divided by 4, 6. Okay. Yes, got the calculation that we were doing yesterday. Then 4 cross 7, 28. Minus 4, 24. 24 by 4, again 6. Okay. And then last element of a row is always 0. Then I take the next row, that is the S power 2. That is the S power 2. Okay. Now, to form the S power 2 row, 6 into 8, 48. Minus 4 into 6, 24. 24 by 6 is 4. Right. Next, 6 into 4. Okay, minus 0, that is the 6 into 4 divided by 6, it is 4. Last element 0. Okay, last element zeros. Okay. Then S raised to the power 1. Coming to the S raised to the power. Now understand what is the new case that you are going to encounter in this question. Okay. S power 1. See, 4 cross 6, 24 minus 4 cross 6, 24, that is 0. Okay. That is 0. Then this is 0 because the top two elements seen here, it is 0, 0. Last element anyway 0. Last element anyway 0. Right? Now, what is the observation, dear students? Quickly, there is an observation that I have a row of zeros. I have a row of 0 entirely. Not only the first element. What is the case that we have seen yesterday was only the first element case. But here you have a complete row of zeros. No, Prakhar, it's not going to be stable. It's not going to be stable. It is not going to be stable. Prakhar, recheck your analysis. Yes, Zayan is correct. Now, how do you deal with the row of zeros? First, I'll tell you the method. Okay, first, I'll tell you the method. Now, the method is the method of auxiliary equation. As I've described the steps. What did I tell you? Step number 1, form the auxiliary equation. Okay, form the auxiliary equation. What is the auxiliary equation? Auxiliary equation is formed by using the coefficients of the row which is just above the row of 0. Row of 0. Okay, that is 4s square. Okay, row of zeros is s square, and what is the coefficient of s square? It is 4s square plus 4 equal to 0. 4s square plus 4. Why only 4? Because alternate terms are there. Even if you want to write, it will be s power 0. Okay, so basically 4s square plus 4 equal to 0. Then do the differentiation of this. Step number 2. What did I tell you? Differentiate this. So what is the differentiation of this? 8s equal to 0. 8s equal to 0. Step number 3, what did I tell you? Step number 3, replace the row of zeros. Replace the row of zeros by by the coefficients of the derivative equation. So the coefficients of the derivative equations is equal to 8. Only one coefficient is there. So let me write down that coefficient on the previous case. Yes, I'll just write down here. And what I am going to form here is the modified s power 1 row. I call this as the modified s power 1 row that has the coefficient 8 and 0, 0. 8, 0, 0. Then what is the s power 0 row? Now proceed with this new modified row. Proceed with the new modified row. So see, just erase the row of zeros. So 4 cross 8 minus 0. So 4 cross 8 divided by 8. This is equal to 4, 0, 0. Right? Okay. Yes. Yes, Harsha, what do you want to say with s equal to 0? What do you want to say with s equal to 0? Yes, is that Raoult array clear to everyone now? Is that Raoult array clear to everyone now? That is a Raoult array with the auxiliary equation. Now what to do further, I'll tell. What to do further now. Okay. Now observation. Now dear students, follow the question with me. I'll tell you the total concept about the auxiliary equation. What is auxiliary equation and what happens if it arrives. Okay. So first of all, let us do the solution. Number of sign changes in the first column. Number of sign changes in the first column is equal to how much? 0. Do you see any sign changes? Do you see any sign changes here? Just look at this. Do you see any sign changes in the entire first column? No. There is no sign change in the entire first column, and that is why what is the number of RHP roots? This must be clear to everyone. That is what we have discussed yesterday. Okay, so number of RHP roots is equal to 0. Okay, number of RHP roots is equal to 0. Okay, because there is no sign changes in the first column. Can I say that the system is stable? Can I say that the system is stable? Okay. Can I say that the system is stable? No, the system is still not stable. The system is not stable. Okay. Now, whether it is unstable or it may be marginally stable, I'll tell you the shortcut and I'll tell you the concept both here. So listen, dear students. Just I have got an auxiliary equation. 4s square plus 4. Listen, everyone. No, it is not stable also. Naresh, it is not stable. 4s square plus 4 equal to 0. Just solve this now. The replacement of the auxiliary equation has been done. And now I'm just trying to solve the equation. I'm just trying to solve the auxiliary equation. This may not be required once I tell you the shortcut. But just listen to the concept first. And then I'll tell you the shortcut for auxiliary equation. Auxiliary equation 4s square plus 4 equal to 0. And s square is equal to minus 1. Which means s is equal to plus minus j. Which means s is equal to plus and minus j. Right. That means, and also take the characteristic equation. Also take the characteristic equation. Number 1. Okay, what is the characteristic equation? S power 5 plus 4s power 4 plus 4s power 4 plus 8s cube 8s square 7s. 8s cube plus 8s square plus 7s plus 4 equal to 0. Yes, Satish, no need to comment it repeatedly. As you can see, I'm in the middle of a question and you are asking something which is out of this case. Okay, so please try to have patience in that case. That will make me leave the question. You can ask me extra thing, but when I'm not solving something, it's otherwise going to disturb the question and all students. S equal to plus j. Okay, when you put s equal to plus j, you are going to see that characteristic equation is satisfied. Plus j or minus j, characteristic equation is satisfied. Now listen very carefully. Okay, listen very carefully. Yes, Harsha, you are right. Whenever there is a row of 0, the system can't be stable. That makes it sure. The system can't be stable. That is 100% sure. Only two possibilities. It may be unstable, it may be marginally stable. And I'm going to give you the shortcut about that. So just let me go to some of the key points which I told I'll be telling with the question. S equal to plus minus j, just calculate j power 5 plus 4, j power 4, 8j cube, 8j square, 7j plus 4. It is going to be satisfied equal to 0. Okay, it is going to be satisfied equal to 0. You can check this, I'll leave this to you. And let me tell you, yes, I'll be going through the key points and step by step, whatever comes I'm going to highlight you. The row of zeros will always be observed in the odd power row. The row of zeros is always observed in the odd power row, correct? The row of zeros is always observed in the odd power row. I'm going to demonstrate this in the upcoming question also, but look at this. Where is the row of 0? This is odd power row. The row of zeros is always observed in the odd power row. Okay, we are going to have another look at this also. Okay. Number 2 key point. Dipankar, what do you want to repeat? The roots of the auxiliary equation will also satisfy the characteristic equation. Okay. That is what has come up here. Okay. Which means that the auxiliary equation is one of the factors of the characteristic equation. I've shown you right now, S equal to plus minus j is nothing but the roots of the auxiliary equation, and the roots of the auxiliary equation is also satisfying the characteristic equation. Okay, Dipankar, I just asked you what to repeat. S equal to plus minus j, that is the roots of the auxiliary equation, and that is also satisfying the characteristic equation. Okay, so roots of auxiliary equation will also satisfy the characteristic equation. That is always going to be true. I will show you in the next question also. And that means what? It basically means one thing, that always whenever you solve auxiliary equation, we are not going to solve, I'll give you the shortcut, just wait for that. But if I solve the auxiliary equation, the roots of auxiliary equation also satisfy the characteristic equation. Okay, that means that for this question, I'll just switch between the slides, just wait. For this question, clearly the system is not stable. Why the system is not stable? Because S equal to plus minus j is S equal to plus minus j also represents the roots of the characteristic equation. Matlab, what type of roots? Pure imaginary pair. And because it is pure imaginary pair, the system is what? Is there any RHP root? That is confirmed. There is no RHP root because of no sign changes. But because of the pure imaginary roots, the system is marginally stable. The system is not stable, but the system is marginally stable. So those who are telling stable, please make the correction. The system is not stable. Actually, the system is marginally stable. Clear, everyone? The system is marginally stable. Fine. Yes. And now if the system is marginally stable, what can I say about the number of LHP roots? That is equal to total degree. What is the total degree? It's a fifth order characteristic equation. 5 minus how many RHP roots? 0. How many j omega roots? 2. Okay, so that is 5 minus 2 and that is equal to 3. Okay, that is equal to 3. Okay, so next thing that I'm going to tell you in the key points. Listen to this, everyone. Okay. The presence of row of zeros may lead to one or more of the following conditions. And what are those conditions? Okay. There is at least one pair of imaginary roots, as I've shown you in this example. Okay. There is at least one pair of imaginary roots that is shown in this problem. Okay. Or one or more of the following conditions may exist. Okay. Next condition, there is at least one pair of real roots having equal magnitudes but opposite signs. Iska kya meaning hai? That also I will show you. Okay. And then there are two pairs of complex conjugate roots located symmetric with respect to imaginary axis. That means only these three conditions. Okay. These are the three conditions when the auxiliary equation arises. Okay. Okay, these are the three conditions when the auxiliary equation arises. That is a pair of imaginary roots. Okay, next, a pair of real roots having equal magnitude but opposite sign. Suppose this is minus a and this is plus a. Okay, this is plus j omega and this is like minus j omega. Okay, pair of imaginary roots or a pair of real roots having equal magnitude but opposite sign. Magnitude is a but plus minus a. And suppose this is x plus jy, so this is what? This is x minus jy, its conjugate, and another pair which is symmetric with respect to y-axis. So this will be minus x plus jy, and this is minus x minus jy. These are the three possibilities that will occur, that may occur. Maybe one of them or maybe one or two of these conditions may exist together. Right now for the current question, what is the possibility for the current question? For the current question, first possibility has come. A pair of imaginary roots has come. Okay. And whenever I solve this equation, see, even if it is imaginary equation, suppose s square plus omega square. How do these roots come into picture? S square plus omega square equal to 0. How does this comes into picture? It is s square minus a square equal to 0. Okay. And how is this going to come in the picture? It is going to come up by the equation of the form s power 4 plus s square plus 1 equal to 0. It is going to come like that. Okay. It is going to come like that. So such possibility of poles, listen everyone, such possibility of poles is only coming when you have what type of equation in S? I am going to take a question on this also, s power 4 plus s square plus 1. Just wait for it. Okay. What type of equation, what type of auxiliary equation you are expecting? What type of auxiliary equation you are expecting when you have these three conditions? You are getting an auxiliary equation. You are getting an auxiliary equation where it has only even powers of s. Suppose this is power 2. This is power 2 and this is power 4, power 2, power 0. So the auxiliary equation contains what? The auxiliary equation can contain only even powers of s. Listen everyone, some of you were asking about that even and odd power. Auxiliary equation can contain yes, Harsha, third conditions do come. Auxiliary equation contains only even powers of s, and because it contains even powers of s, the row of 0 is observed up below that. The row of 0 is observed below that is in the odd power. Okay. The row of 0 is always observed in the odd power row, first point. Okay. Every root of auxiliary equation will satisfy characteristic equation. Every root will satisfy characteristic equation. Okay. And whenever you have a row of 0, one or more of this will always be true. One or more of these conditions will always be true. Okay. Yeah. There is another possibility that within a Routh array, okay, two rows become zeros. There is another possibility. Within a Routh array, two rows of the Routh array become 0. Two rows of the Routh array become 0. Okay. And whenever two rows become 0, then it indicates the possibility of repeated pair of imaginary roots. And whenever I told you yesterday, whenever there is repeated pair of imaginary roots, then in such a case the system is unstable. One pair of imaginary roots is marginally stable, but repeated pair on the same location, it is unstable. I explained you yesterday. I hope you remember that. I've explained you yesterday. Okay. So these are all the possibilities. It is very important to know the possibility. Then only you will be able to understand the questions based on the Routh, based on the auxiliary equation, right? Chaliye. So that is what, going back to the question. First I solved the auxiliary equation, plus minus j. Okay. Plus minus j also satisfy the characteristic equation. It will satisfy everywhere. Okay. And number of sign changes in first column was 0. So the number of RHP roots is 0. Okay, and hence no RHP roots, only what? Pure imaginary roots, and due to which the system is marginally stable. Okay, the system is marginally stable. It is neither stable nor unstable. It is a marginally stable case. Okay, and how many LHP roots? It is obviously 5 minus 0 plus 2. Right. Now I'm going to tell you one thing. You might be thinking, sir, maybe the auxiliary equation is complicated. Do I need to solve it every time? No, you do not need to solve the auxiliary equation. I will just solve it in one or two questions to explain you the concept. But in your questions, in the MCQ or NET question, you are not going to solve the auxiliary equation. You can directly say the answer ki how many j omega roots or how many LHP roots. See, how did I come to know ki j omega roots hai? Because solving the auxiliary equation. And one more thing. Sometimes students take it directly कि whenever there is an auxiliary equation, there will be j omega roots. That is also wrong. Sometimes students take it directly because I've shown you second possibility, and I'll show you with the question also. See, look at this second possibility. Look at this second possibility. Here, there is no imaginary axis roots. Characteristic equation aayega, auxiliary equation will come, but there is no imaginary root. So that is also possible. So every time you get an auxiliary equation, do not conclude that there is going to be j omega roots. Okay. Now listen to this. Very important for your approach, for the MCQ and NET approach. What is the shortcut for the auxiliary equation roots? What is the shortcut for the auxiliary equation roots? That is, only for the auxiliary equation roots, the number of LHP roots is equal to number of RHP roots always, and that is equal to number of sign changes below the auxiliary equation. So see what you are going to do. See, dear student, just understand this method. What you are going to do, take the auxiliary equation, take a table containing auxiliary equation and characteristic equation. Take a table containing the auxiliary equation and the characteristic equation. Auxiliary equation and the characteristic equation. Let's take a table containing that. Okay. And then write down the order first of all. What is the order of the auxiliary equation obtained here? In this question, what is the auxiliary equation order? 4s square plus 4. It's a second order auxiliary equation. Okay. What is the order of the characteristic equation? That is given in the question. It is the fifth order equation. Understand this shortcut. Okay. Understand this shortcut for the auxiliary equation roots. Okay, and what I have mentioned for auxiliary equation, always the number of LHP roots and number of RHP roots will be same, and that is equal to number of sign changes below the auxiliary equation. Below the auxiliary equation. So look at this. Look at this. This was my Routh array. Coming back to my Routh array. Where is my auxiliary equation? I'll just highlight. This is my auxiliary equation. Right, this is my auxiliary equation, and look at the number of sign changes below the auxiliary equation. Look at the number of sign changes below the auxiliary equation. So please tell me, is there any sign change below the auxiliary equation? Is there any sign change below the auxiliary equation? No, there is no sign change below the auxiliary equation. There is no sign change below the auxiliary equation. Okay. Below the auxiliary equation only you have to see. So I will write down what is the number of LHP roots for the auxiliary equation is equal to the number of RHP roots for the auxiliary equations, and both are always same and equal to 0. Okay, equal to 0. Number of sign changes below the auxiliary equation, that is equal to 0. Right? That is equal to 0. Now tell me, for the auxiliary equation, this is what only I am solving about the auxiliary equation. So how many j omega axis roots? How many j omega axis roots? So see the total order. Total order is how much? 2. Minus, subtract the LHP and RHP roots. So how many LHP? 0. How many RHP? 0. So how many j omega roots? It is 2. That is what I have shown you here. Na? There are 2 j omega roots. There are 2 j omega roots. After solving the AE, after solving the auxiliary equation table, go to the characteristic equation table. Characteristic equation mein sabse pehle write down the RHP roots. How many? How do you determine the number of RHP roots for the entire characteristic equation? Number of sign changes for the entire Routh array, first column. The same methods that we have followed yesterday. That is equal to 0. That is equal to 0. Okay. Then write down for characteristic equation, what is the order of results that you will write? For characteristic equation, number 1 RHP, then write j omega, and then write LHP. So how many RHP roots? Okay, that is obtained by the auxiliary equation. Sorry, not RHP. How many j omega roots? That is obtained by the j omega axis roots, and that is equal to 2. So now you will write down ki how many RHP roots will come, and RHP roots will be 5 minus how many LHP roots? It will be 5 minus RHP and j omega roots combined. So this answer is equal to 3. What you only need to do in your questions now, solve the auxiliary equation to just replace the row of zeros. To just replace the row of zeros. You don't have to find the roots of auxiliary equation and then check the stability. Okay, that was just for the concept and key points. But actually, just solve this table and give the answer. Okay, what is the comment? That the system is marginally stable. That I have commented clearly. Yes, is that clear to everyone? So that will take more problems now. Yes, is that clear to everyone? Yes, good evening, Anurag. Are you joining just now? Yes, clear to all? Students, yes, come on, kindly comment so that I start the next question immediately. Let us take one or two questions together and then we'll move on towards the next case. So another question is there on the screen. Start forming the Routh array quickly. Start forming the Routh array quickly. Yes. Yeah, Venkatadri, I just now made it clear ki why we consider the auxiliary equation in even powers only. I was explaining that before some time. The same thing. Yes. Let us now start solving the Routh array. Highest power of s is s power 6. So you will start with the row of s raised to the power 6 and s raised to the power 5. Yes, s power 6 and s power 5. The coefficients will be 1, 5, 2, minus 8. Acha, just looking into the question. Is the system stable or not? I'm only asking about stability, yes or no. Can the system be stable? Looking into the question, you can say. I'm not telling you to comment on marginally stable or unstable, but whether it can be stable or not. Just yes or no answer. Okay, so what is the first set of coefficients? 1, 5, alternate 2 and minus 8. 1, 5, 2 and minus 8. And then other alternate pair. 1, 3, minus 4. 1, 3, minus 4, 0. Yeah, by looking into the equation, you can say unstable. Why? Because all the coefficients are not of the same sign. Necessary condition is missing. Necessary condition has failed. S power 4 will form the row now. 5 minus 3 by 1, that is 2. 2 minus minus 2, that is 6. 1 into minus 8 divided by 1, minus 8, and then 0. Last element 0. Right. S raised to the power 3. Okay. Yeah, exactly. Necessary condition. Good observation by all the students. Necessary condition has failed. Now S power 3. Okay. S power 3. So 2 cross 3, 6 minus 6, 0. Next. 2 cross minus 4, minus 8. Minus of minus 8, 0. Okay. Next. This is 0 because top two elements are 0. Last element is always 0. Okay. So you are clearly getting, dear students, you have a row of s raised to the power 3. You have a row of s raised to the power 3 which is entirely row of zeros. Again, you see that row of zeros is always observed in the odd power. S power 3, it is observed in the odd power only. Okay, so now try to make the auxiliary equation, and this will be your auxiliary equation. This will give you the auxiliary equation. Okay, this will give you the auxiliary equation. So let me write down the auxiliary equation. Yes. What is the auxiliary equation that I am obtaining? Just a second. That is 2s raised to the power 4, 6s square minus 8 equal to 0. Yes, Atharva, correct answer. Atharva's correct answer. Unstable with the, I don't only want stable, unstable. When you're commenting the answer, say the number of roots also. What roots are lying. 2s power 4 plus 6s square minus 8 equal to 0. What is the next step? D by ds. That is 8s cube plus 12s equal to 0. And then what is the next step? Replace the row of zeros. Okay, so s power 3 row will be equal to what? 8, 12, 0. Coefficients of the differentiated equation. So I'll write down here. This is going to be your modified s power 3 row, and that has come up as 8, 12 0 0. ठीक है. Next, S square row. S square, तो see 8 cross 6, 48 minus 24 is 24. 24 by 8, this is 3. ठीक है. Next, 8 into minus 8 divided by 8, so that is minus 8. Okay, next it is going to be 0 because these elements are seen to be 0. Last element is always 0. Then the S power 1, 3 into 12, how much? 36 minus 8, minus minus plus हो जाएगा, तो 64 plus 36, 100 divided by 3, so 0 0 0. And then coming to the S raised to the power 0, 100 by 3 into minus 8 divide by 100 by 3, so I get minus 8, then 0, then 0, then 0. Okay, and is there any sign changes in the first column? Any sign changes in the first column? Yes, there is one sign change in the first column. Okay, right? Yeah, Sriram, if that occurs, suppose if that occurs, should that, no, for RHP roots you have to go below. If that, what you want to say, just let me read. If that occurs at the row of auxiliary equation, then we should consider that sign change. Yes, you should consider. You should consider that. Now, listen, dear students. Now, listen, everyone. Previous question I have explained you by solving auxiliary equation. If required, I'll explain you this one also. But let us solve this with the shortcut. Let us complete the answer first. Now, what is the shortcut? Very quickly, let us solve the answer. So, I will make a table. Auxiliary equation, very quickly, and characteristic equation. What is first you have to do? What is the first you have to do? Write down the order. Write down the order of both. What is the order of auxiliary equation? In this question, it is 4. What is the order of the characteristic equation? Given is 6. Okay. For auxiliary equation, LHP and RHP roots, number of LHP and number of RHP roots is same. That is equal to number of sign changes below the auxiliary equation. So I will show you. Yes, there is a sign change below the auxiliary equation, that highlighted auxiliary equation. Below that there is one sign change. Below that there is one sign change. So I'll write down the answer here as 1. Okay. So how many j omega roots? It is 4 minus 1, matlab 1 each, 1 LHP and 1 RHP. 1 LHP, 1 RHP. So 4 minus 1 plus 1, kitna hua? It is equal to 2. So 2 imaginary roots will be there. Okay. Will be 2. Now, yes, it is common, 1 and 1 each. Now, come to the characteristic equation. What is the order I told for the characteristic equation? RHP. First solve the RHP roots. RHP matlab total number of sign changes in the first column, and total number of sign change also I have shown you, it is 1. Then route j omega. How do you write j omega? That is by the auxiliary equation table. So j omega will be equal to 2. Okay. And then finally write the LHP roots. That is 3 minus 1 plus 2. Sorry, 6. Order is 6. 6 minus 1 plus 2 and 3 LHP roots. That is the answer. And overall stability, even if there is one RHP root, the system is unstable because of this. Because of this itself, you can say that the system is unstable. So that is the final answer. 1 RHP roots, 2 j omega roots and 3 LHP roots. Everything is important because recently, many a times there have been questions in the GATE and ESE where they are not only asking about the stability, but they are asking about the quantity of the LHP or RHP roots. So you must clearly be able to define that quantity also. That is important. You must be able to define the quantity also. That is important, right? Okay, so please deal the question accordingly. Yes, is that clear to everyone? Yes. Now again, once again for explanation. Just a second. Yes. Is that method clear and simple? It's a very shortest method to solve the questions based on the auxiliary equation. So it's a very shortest method to solve the auxiliary equation questions now. Now, okay, before going to the next question, I would like to do one small activity once again. Like to do one small activity once again. Okay. Yes. So, what is the auxiliary equation? The auxiliary equation 2s power 4 plus 6s square minus 8 equal to 0. I am explaining you the possibilities once again in detail. Otherwise, the question is solved there. For the MCQ or NET type question, आपका solve हो गया है. Let us just explore some more concepts. Cancel out the 2. 3s square minus 4 equal to 0. Okay. Yeah, Sriram, just let me go to the next question, then I will read it with a peaceful mind. Just wait a minute. Let me complete with the concept. So s square, if I just try to solve this, it is going to be factorized at s square plus 4, s square minus 1 equal to 0. See, it is factorized. Okay, it is factorized. So what are the values of s square? It is minus 4 and 1. So what is the value of s? Plus minus 2j, and under root of 1 is plus minus 1. Now look at the possibility once again. Look at the possibility once again. I am solving this auxiliary equation to tell you the possibilities. See, you have seen the pair of j omega roots, and you are also seeing what is that one RHP root. What is that one RHP root? See, basically one more thing. I'll tell you the limitations of Routh-Hurwitz. Routh-Hurwitz can't tell the exact root. You are getting the exact root because I'm solving the auxiliary equation in detail, and every solution of auxiliary equation is also a solution of characteristic equation. Okay, once again, I've told you with the last question, once again you can satisfy. Take the characteristic equation and put plus minus 2j or plus minus 1. It is going to be satisfied 110%. It is going to be satisfied. Okay, so while solving the auxiliary equation, I am getting that yes, there is a pair of j omega roots and there is one RHP roots. Okay. And what are the possibilities? Let me go to the key points again. Let me go to the theory again and see what are the possibilities that have come up for this question. For this current question, what is the possibilities that has come up? I told you, whenever there is an auxiliary equation, whenever there is a row of zeros, one or more of those conditions will exist. So in this question, this is also true, a pair of imaginary roots plus minus 2j, and what is also true, minus 1 and plus 1, the second condition. Okay, there is at least one pair of real roots having equal magnitude but opposite sign. That is also true. Okay, so that is why I told one of the given conditions or maybe more than one of the given conditions may also true whenever you have an auxiliary equation question, whenever you have a row of zeros. Clear? Yes, is that clear, everyone? But once again, I say, if you are solving the proper MCQ question, you don't have to show what are the roots of auxiliary equation. This is just for your explanation, but your question is solved by one simple table. One simple table. That's it. That is what the shortcut you have to remember. Right, everyone? Right, everyone? Yes, if you are understanding, if you are liking the shortcut, do like the YouTube like button also. Don't just like the shortcut, like the YouTube like button. Just press the like button, and with that motivation, let me take another question now. Come up to this question. Okay. Come up to this question. It's a GATE 17 2-mark question. It's a GATE 17 2-mark question. Read and give me the answer. Take 2 minutes of time. Read and give me. I want correct answers. Just take 2 minutes of time and give the correct answers. Yes. No, Sriram, now I am reading your comment little peacefully. So you are asking actually about the sign changes. So sign changes will be one. If there is any other sign change below, that is a separate case. That is a separate case. But auxiliary equation is like one other. Auxiliary equation, treat auxiliary equation as one new equation. And that equation starts with s power 4 only. Okay. So if that is negative and if you go to positive, it is just one sign change. Now, when you are solving auxiliary equation, you are not bothered about what is above that. What is above that? Okay. Okay, is that clear? I think Sriram, I have read your comment properly now. Yes, get to the answer. Now an equation what is this? This is an equation, given an equation which is containing only alternate powers. So it is sure to get auxiliary equation here. This is an equation, this is a question containing only alternate powers. Which of the following option is true? Which of the following option is true? Yes, come on. Which of the following option is true? Yes, anyone with the answer? Which one of the following option correctly describes the location of the roots of the equation s power 4 plus s square plus 1 equal to 0? Atharva, correct. See, given s power 4 plus s square plus 1 equal to 0. Okay. And if that is given, I'll just write down here s raised to the power 4 plus s square. Rahul and Manish, please recheck. Plus 1 equal to 0. S power 4 plus s square plus 1 equal to 0. Okay. S power 4 plus 0s cube plus s square plus 0 into s plus 1. First of all, by looking into the question itself, the question is not asking stability, it is asking the quantity of roots. But by looking into the question, you can say, yes, it can't be stable because second necessary condition is failed now. What is the second necessary conditions? None of the coefficients should be missing. So, यहाँ पे there are coefficients missing. Okay. So, when you start making the Routh array, s power 4 and s power 3, okay. Yes, Atharva, this itself is going to be the auxiliary equation. So s power 4, all alternate coefficients are 1, 1, 1. But what is the coefficient of s cube? S, all are 0. Okay, all are 0. So the characteristic equation itself here, what is the condition existing here? The characteristic equation here itself is the auxiliary equation. The auxiliary equation, that is what the condition is existing here, correct? Okay. And then you have a row of zeros, okay. Diksha and Zain, correct answer. Chandrakala, please recheck. Okay. Chandrakala, Rahul, Manish and Diksha, please recheck. Now Diksha has given correct. Yes, Sriram, correct. Row of zeros, and whenever you have the row of zeros, I write the auxiliary equation, and that is the same as the given equation s power 4 plus s square plus 1 equal to 0. Here in this case it is same as characteristic equation, but anyways, let us proceed with the regular procedure. D by ds, that is 4s cube plus 2s equal to 0, differentiating. So what are the new coefficients now? What will be the s power 3 modified row? Will be replaced by 420. Okay. Yes, Manish, Satvik and Rahul, now correct answer. S raised to the power 3, 4, 2 zeros. It is replaced by the derivative coefficients, derivative equation coefficient, that is 4, 2 and 0. Okay. And then solve the Routh array in the regular manner. So next what is going to come is obviously s square. And what is s square? Obviously, don't count the elements of the row of zeros. This is separated. So this is 4 minus 2. That is 2. 2 divided by 4, half, 0.5. Okay. 4 into 1 minus 0. Okay. That is just 4. 4 divided by 4. So next is 1. Last element always 0, right? And then, yes, Geeta Shri and Subramanyam, correct answer. S raised to the power 1. 0.5 into 2. 1. 1 minus 4. Minus 3 divided by 0.5. 1 minus 4. Minus 3 divided by 0.5. So let me directly write it as minus 6. Okay. And then this is 0. This is 0 because the top column is 0 and last element is always 0. s raised to the power 0 row, s raised to the power 0 row, and that is minus 6 into 1 divided by minus 6, that is plus 1. This is 0 because top two elements are 0 only and last element always 0. And just notice the number of sign changes. Just notice the number of sign changes. It is plus to minus, minus to plus. Two sign changes. Two sign changes. How will you write down the answers? How will you write down the answers? You will write down the answers by the shortcut method only. Okay, you will write down the answer by the shortcut method only. So shortcut method involves auxiliary equation and characteristic equation table. Just that simple table is enough to give you the right answers. Yes, Ramya, correct answer. What is the order of the characteristic equation and auxiliary equation? They are the same here. Order 4. Now once again I repeat, what is the sequence that you follow for the auxiliary equation? सबसे पहले you write down the number of LHP roots and number of RHP roots, that is always same, and that is equal to what? That is equal to number of sign changes below the auxiliary equation. So I'll go back to the router and I'll show you. Below, this is the auxiliary equation itself. So below the auxiliary equation, how many sign changes? 2. Plus 2 minus 0.5 से minus 6, minus 2 plus minus 6 to 1, 2 sign changes, and let me fill up the answer then. So that is equal to 2. That is equal to 2. Okay, so how many j omega axis roots? It will be 4 minus 2 means 2 each, 2 LHP, 2 RHP. So 2 plus 2, 2 LHP, 2 RHP, and no j omega axis roots. Okay, I have told you clearly this is a common mistake if you don't follow this concept. The common mistake done by the students कि auxiliary equation आया है तो there has to be j omega roots. This is a common perception taken. कि auxiliary equation has come, so there should be j omega roots, but that is not necessary. What are all the possibilities I have shown you in the previous slides, right? Okay. Now, characteristic equation, although it is same, so just follow the same results here because the characteristic equation and auxiliary equation is same. Okay. Otherwise, what is the sequence you follow? For the characteristic equation, you first write down the RHP roots, then you write down the j omega axis roots, and then you calculate the LHP root. That is the sequence for characteristic equation. Here it is just copied because coincidentally the characteristic equation, auxiliary equation, both are same. Okay, so how many RHP roots here? How many RHP roots here? Okay, so if I see with respect to characteristic equation sees the total number of sign changes in the first column, and that is equal to 2. Okay, how many j omega? J omega answer is taken as I have told earlier. J omega answer is just basically copied from the auxiliary equation. So j omega answer is 0, sorry, and LHP it is 4 minus LHP is 4 minus 2 plus 0, and that is equal to 2. That is equal to 2. The final answer. The final answer. And the system is unstable. But what is the question now? What is the option? It has 4 LHP roots? Wrong. It has 1 RHP and 1 LHP and 2 j omega roots? Wrong. It has 2 LHP and 2 RHP roots? Yes, sir, right. Yes, sir, absolutely right. All 4 roots on the imaginary axis? Wrong. Option C is correct. Okay. Option C is correct. Clear? And once again, if you want to go for the detailed analysis, question is solved, what about the details? What about the detailed analysis? Not required in the question. In the exam, it is not required. Just again, I am telling. For details, if you solve the auxiliary equation, that is s power 4 plus s square plus 1 equal to 0. Okay. Solving this, you are going to get what picture? Okay. First of all, you get the value of s square. Let s square be equal to x. And that is equal to minus 1 plus minus j root 3 by 2, solving this quadratic equation. And then find the value of s. S means under root of these complex numbers. Okay, that will be complex numbers only. Under root of complex numbers will be complex. Finally, the picture that you are going to get, no need to solve it completely. Finally, the picture that you are going to get is this. That is The condition number 3, which I was referring to in the key points. Condition number 3. So I have taken questions to show you all the conditions. I have taken questions to show you all the conditions. Pair of imaginary roots, a pair of real roots equal magnitude opposite sign, and two pairs of complex conjugate roots which are symmetric with respect to the y-axis, with respect to the j omega axis. Okay. You can solve this. You can just solve this if you want. Not required for this question, not required in the exam, but just solve it for your interest if you want. For your interest in due form. Okay. Question is solved there. Option number C I have marked. Yes. Clear? So that's the simplest way. That's a very shortcut way to solve the auxiliary equation questions. To solve the auxiliary equation questions. Right. And with that, let me just give you an hint about what are the limitations of the Routh-Hurwitz analysis. Number one, it is applicable only for polynomial equations. Polynomial equations, as I've been telling you till now. Okay. Equations of the form, polynomial equations are what? Which are equations of the form of s power n. Okay. It can be any power of n. Suppose s power 5 plus 3s power 4 plus 8s cube plus something. These are known as polynomial equations, polynomial functions. Okay. Apart from that, it is applicable only when the coefficients are real. If you have an imaginary coefficient matlab like here it is 1, here it is 3, here it is 8, all are real. Whether it is positive or negative does not matter, but all the coefficients should be real for application of Routh. Okay. It is applicable only for polynomial equations. Now, if it is applicable only for polynomial equation, just listen to this point. Suppose if you have a characteristic equation. Just a second. Yeah. Suppose if you have a characteristic equation of the form s square s cube plus 2s square plus e raised to the power minus 2s equal to 0. Okay. What can you do? Okay. Maybe you can approximate this. Maybe you can, because when you have an exponential term coming up, matlab the equation is not a polynomial now. It is a non-polynomial case. Okay. So it's an approximate analysis, an approximate by Taylor series. Okay. Yes, Saurabh Anand, even I am not sure, because YouTube content is little random and I am not sure till when I am having the YouTube series. Yeah, one thing I am sure I am starting control system in the target batch this Sunday itself. Okay, I'll just tell you for all, I am going to start in the target 2021 batch which has been launched by the GradeUp. Okay. And if you just, that's a paid course available on the GradeUp app with all complete subjects, all test series, all study material, everything in sequence. A systematic course जिसे बोलते हैं. Okay. So I am going to start control system on Sunday, this Sunday itself, and then I'm having regular classes there. So maybe because of that, my YouTube classes will be there next week or not, that I don't know right now. It will be informed to me. Okay. So, if you want each and everything, like I've completed recently vision batch control, I'm going to target. Obviously in the patch we have each and everything from A to Z, from 0 to 100. A to Z of theory, 0 to 100 level of the questions. That is what I target in my course. Okay. Obviously I will try to take on YouTube also, but that depends on what is given to me. I know what is my availability once I go to the target 21 batch, and I'm starting control system from this Sunday itself on the target gate 21 batch, right? Chaliye, yeah, so you can approximate this by Taylor. Let me come back to the topic, but that's just an approximation. That is just an approximation. Okay. It's such cases are better handled by Bode or Nyquist plots. Okay. And with the concepts of stability के लिए, with the concepts of gain margin and phase margin. That is a better way once you have a exponential term coming up. Routh is not the appropriate method of dealing with, because even if you approximate, you'll approximate up to what order? second order, third order, fourth order. The better number of terms you take, better is the answer, but more lengthy the question becomes. Okay. So just remember the limitations of the route, and apart from that, what is the other limitation? It can only tell the quantity of RHP routes but not their location. Okay. See, in some of the questions, listen everyone, in some of the questions I have told you the location. That is because we solved the auxiliary equation. That is not a part of the route array. I am just asking with respect to a route array, and that can only tell the quantity, how many LHP, how many RHP. Okay. And also it can't distinguish between real and complex routes. For example, last question. Okay. Last question, you have 4 complex routes, but how did you come to know that it is 4 complex routes? How did you come to know it is 4 complex routes? Because you solved the equation once again. That is your extra effort. But with respect to route array and this shortcut also, what you are only getting is how many RHP2 and how many LHP2. It is only telling the region. But whether the 2 RHP routes and 2 LHP routes, whether they are real, okay, whether they are complex, is that given by the route array? That is not specified by the route array. Okay, so that is also counted as one of the limitation of the route array. It can't distinguish between real and complex routes. You have distinguished by your extra efforts. We are solving detail. Okay. Yes, is that clear to everyone? Right. So these are the limitations of the route array, and with that, let's take another important question. Now I'm taking a mains question basically. The open loop transfer function of a unity feedback system is given to you. K by s plus 2, s plus 4, s square plus 6s plus 25. Find the values of k which will cause sustained oscillations in the closed loop system. And what are the corresponding oscillation frequency? Yes, Diksha. See, absolute stability is just like what you are studying right now. Like Routh-Hurwitz. What is Routh-Hurwitz telling you? Whether the system is stable or not. Yes or no answer. It is just telling you the quality of the system. Stable, unstable, or marginally stable. That is absolute stability method. Relative stability means to compare the stability of 2 systems. Suppose 2 systems are stable. Which of them is more stable? Can Routh-Hurwitz say that? Nahi. Routh-Hurwitz will say both are stable, but which of them is more stable? Okay, that is found using the concept of gain margin and phase margin by the methods of Nyquist and Bode. And when we go to relative stability, we have the methods of Nyquist and Bode, and there we also discuss about the gain and the phase margins. Right, everyone? Yes, Diksha, is that clear? That is the basic difference between absolute and relative stability, what I could say in a 1 minute time. Yes. Find the values of k which will cause sustained oscillations. Everyone knows sustained oscillations means pure oscillations. Okay, pure oscillatory system. So question is asking what? First of all, find the value of k that will cause. For a reason, I have taken an ESE mains question because I want you to explain one important category here. Sustained oscillations. Okay, means the system is pure oscillatory. The system is pure oscillatory, and hence the system is marginally stable. Okay. So what are the conditions for the system to be marginally stable that you know? So let us start solving this by the Routh-Hurwitz analysis. And then what are the corresponding oscillation frequency? That also I will explain you to how to solve this. Okay. So let us start with this question. To start this question, first form the characteristic equation. Characteristic equation is given by 1 plus GSHS equal to 0. Okay. Now GS is given to you, unity feedback, so HS is 1, so write down 1 plus GSHS, that is K upon S plus 2 S plus 4 multiplied by S plus 2 S plus 4 S square plus 6S plus 25 equal to 0. HS is 1. Okay, HS is 1. Now simplifying this, the first term is how much? S square plus, that is what is given, S plus 2 S plus 4 S square plus 6S plus 25. Yeah, that is s square plus 6s plus 8, s square plus 6s plus 25 plus k equal to 0. Multiplying that term with the 1. Okay, so that is what I get, s square plus 246 plus 288. So now this is solved as, let us solve this term by term. S square plus 6s multiplied, matlab s square plus 6s का तो square ही ले लेते, तो that is s power 4 plus 36s square, ठीक है, plus 2 6 12 s cube, okay, plus 25 with this, so 25 s square plus 25 into 6 150s plus 8 s square plus 8 6 48s plus 8 into 25 200 plus k equal to 0, okay. Now let us just rearrange the terms and write down the final characteristic equation. The characteristic equation that is coming is s power 4, s cube terms. What is the s cube term? This is it, 12s cube. S cube. Just first you have to write down the characteristic equation clearly. 12s cube. What is next? Okay. What is next? S square. So the 36s square, 25s square and 8s square. So 36, 25 is how much? 50, 61 and 8, 69s square. 69s square. Okay. And then look at the terms of s. Okay. 150s, 48s. So that is 198s. 198s plus the constant 200 plus k equal to 0. Just tally your characteristic equation first. Just tally your characteristic equation first, and then I start making the Routh array, the first two rows, and I'll explain you this question. S power 4 and s power 3, right? Alternate coefficients 1, 69, 200 plus k. Okay. And then s cube 12, 198, 0. Yes, characteristic equation matching with everyone. Have you solved the characteristic equation till now? Now, what is s squared? 12 into 69. Let's do this with the calculator quickly. So, 12 into 69. Put down the value in your calculator. Minus 198, and that is divided by 12. So, I am getting this one as 52.5. 12 into 200 plus k divided by 12. So, that is 200 plus k. 0. Okay. Then what is s raised to the power 1 row? What is s raised to the power 1 row? So that is 52.5 multiplied by 198, okay, minus 1200 into 2. So that is 2400. So this will be written as 7995 minus 12k. Minus 12k is divided by 52.5, 0, 0. And then s raised to the power 0. This is just one term. So x into 200 plus k divided by x. So that is 200 plus k, 0, 0. Right? Got this one? Got this one? Now understand how to solve this question. The question is asking marginal stable case and the frequency of oscillation. Just understand how will we approach this question. Okay. Let us just understand how we are going to approach this question. Yes. Chaliye. Okay. So now we want, yes, we want the system to be marginally stable. Yes. We want the system to be marginally stable. Okay. Right. And marginally stable is the case when you have j omega axis roots. Now, just relate everything. Marginally stable is the case when you have j omega axis roots. J omega axis roots can only come if there is an auxiliary equation. Without auxiliary equation, j omega roots cannot come. Okay. And auxiliary equation means you should have a row of zeros. Okay. Row of zeros is observed only in the odd power. It is only observed in the odd power. So everything is linked up. Everything is linked up. Okay. Now, odd power means, look at this. Okay. Obviously, you can't make the s power 3 as 0 na, because the coefficients are fixed. 12 and 198, that is fixed. Okay. So s power 0. Take the s power 0 row. Oh, sorry, s power 1 row. You will have to take the s power 1 row. Okay, that is the odd power row. Okay, so make this as 0, s power 1 row. The other two elements are 0 only. What you have to take is the first element, that is 7. Yahan pe I am taking the s power 1 row, and for that 7995 minus 12k should be equal to 0. 7955 minus 12k, just take the numerator equal to 0. Solving this, what is the value of k? 7995 divided by 12. Yes, Sriram, Zayan, Kavita. No, Kavita, I'm not asking the range. The final value 665. Yes, Atharva and Harsha. The k is coming up as 666.25. Okay. Now that is one part of the answer. What is the value of k that will cause sustained oscillation in the closed loop system? Is this. This is one answer. Okay, that is one answer. But then next question. Okay. Then next question. What is the frequency of oscillation? See, just listen to this by a very, very simple understanding. Okay. Frequency of oscillations come for an oscillatory system. An oscillatory system, as I've told, it is the marginally stable system, j omega roots. So suppose if you take cos omega t, what is the Laplace transform for cos omega t? It is s divided by s square plus omega square. Okay, s square plus omega square. Okay. Yeah, Satvik, that will come true by the auxiliary equation. If I follow the auxiliary equation, I'm going to start the auxiliary equation. So, what are the poles in this case? S is equal to plus minus j omega. Solving the denominator, what are the poles? S equal to plus minus j omega. Okay. Where omega is ultimately what? The frequency of oscillation. When I say there is a sinusoidal signal cos omega t, everyone knows now what is the frequency of cos omega t. The omega itself is known as the natural frequency of the cos omega t, and t equal to 2 pi by omega is known as the time period. Okay. So if omega is the frequency, then you get the poles. Okay. Poles are also known as what? Poles matlab the roots of the characteristic equation are given by plus minus j omega. Plus minus j omega, where omega is the oscillating frequency. Okay. So in this question, coming back to the question, what is the auxiliary equation? Because I have a row of zeros, this is only one part. What is the value of k? K is solved, but what is the frequency of oscillation? Because at k equal to 666.25, I have a marginally stable system, and the marginally stable system, we all know, marginally stable system means it is an oscillatory system. So if it is oscillating, it should have a frequency. So for that, take the auxiliary equation. How do you form the auxiliary equation that you have learned above the row of zeros? Okay, by this one, s square. By this is going to form your auxiliary equation. I'll just highlight this again. This is going to form your auxiliary equation. Right. This is going to form my auxiliary equation. So what is my auxiliary equation? 52.5 s square plus what? Plus 200 plus k equals 0. Okay, put down the k value. Okay, put down the value of k, 666.25. Okay, so solving that, you get s square equal to minus of 200 plus 666 is 866.25 divided by 52.5. And what shall be the answer here? 866.25 is divided by 52.5. This is coming up as minus 16.5. Taking the under root, I am getting s is equal to plus minus j 4.06. Yes, 4.06. Atharva, 4.1 is also correct approximately. Okay, and then this is plus minus j omega. So what is the frequency of oscillation? It is 4.06. The frequency of oscillation is 4.06. Correct? That is the second part of the answer. Frequency of oscillation is 4.06, solved by the Routh-Hurwitz method. Okay, anyways, it's a fourth order control system. We can't solve it analytically. Frequency of oscillation you can solve analytically, mathematically up to second order, that is okay. But third, fourth, fifth order, you can follow the frequency of oscillation by Routh-Hurwitz method. By the Routh-Hurwitz method. Correct? Yes, by the Routh-Hurwitz method. Is that question clear to everyone? Okay, is that question, because that's an important question. That's an important question, and I'll show you one thing here. Okay, if this is clear, you should be able to take another question now. And if that is clear, I take up a question. See, it has been repeated, I don't know at how many places. Just look at this. It has been repeated to so many of places. It has been asked GATE only thrice. It has been asked in GATE only thrice. GATE 2006, same question, same data. Usually it does not happen with GATE, but it has happened. GATE 2006, GATE 2012, GATE 2017, 2 marks. It has been asked in the ISRO paper. It has been asked in the mains examination also. So it has been asked n number of places. So very important question. Very important question. Okay. Yes, come on, try and solve this. Take 2 minutes of time and give me the answer for this. Try to solve this. Because the question is on the same concept. The oscillate, the figure below oscillates at the, here, last question I asked you the frequency. Here the frequency is given. 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 Yes, Manish. Frequency is given, but the concept will be the same. You have to find the value of K and A. Yes, that is how you find the frequency. Very important question, dear students. Very important question, and with the very important question, do hit the like button. Do share the link of this video and subscribe the Grade Up Gate YouTube channel. Do hit the like button immediately for this very, very important question. First of all, carefully form the characteristic equation by taking this one, by taking this system given to you. Characteristic equation 1 plus GSHS equal to 0. 1 plus K S plus 1 divided by S cube plus AS square, S cube plus AS square plus 2S plus 1 is equal to 0. S cube plus AS square plus 2S plus 1 equal to 0. Right? Okay. So what's that? It is S cube plus AS square plus 2S plus 1 plus KS plus K equal to 0. Okay. So S cube, ultimately arranging the terms, AS square plus 2 plus K, 2 plus KS plus K plus 1, K plus 1 equals 0. This is the characteristic equation, only a cubic one, right? Only a cubic one. Okay, very, very important question. Okay, yes, Diksha, correct answer. Sriram, Zayan, correct answer. Manish had given earlier only. Yes, very good, dear students. So see, because now, very repeated question, but the type of expected question you can say level, at least the level you are able to see what level is coming in. It has been asked in mains, it has been asked in GATE, it has been asked in ISRO. Yes. Come on. Now the Routh array. Okay, now forming the Routh array to solve this question, we have S power 3 and S power 2 as the first two rows. Right, S power 3 row coefficients is 1 and K plus 2, and S square coefficient is, this is alternate and this is alternate, A and K plus 1. This is A, K plus 1, right? So what is S power 1 coefficient now? S power 1, it is A times K plus 2 cross multiply, reverse cross multiply, minus K plus 1 is divided by A. Okay. Last element 0. S raised to the power 0. Look at the S raised to the power 0. Okay, so this is a complete term. Let's say this is equal to x, x into K plus 1 divided by x, so that is K plus 1. Last element of a row is anyway 0. right? Now, similar concept. Yes, Harsha, correct answer. Similar concept that I will apply, that we want, question में क्या बोला है, so that the system oscillates, ठीक है, so given that the system oscillates, ठीक है, oscillates at what, 2 radian per seconds, that means the system is marginally stable. The system is marginally stable, ठीक है, marginally stable with roots plus minus j2, ठीक है, plus minus, because what is the roots, I've told you na, plus minus j omega, that is plus minus j2. Okay. Yes, Harsha, I had given this in the ESC class. I'm taking it here also because not only ESC mains, it has been asked in GATE and ISRO. So for the sake of MCQ question also, I'm taking this. So better you have got the answer for this also. That's good. Marginally stable with roots plus minus J2. Okay. And if the system is marginally stable, then there should be row of zeros. There should be row of zeros. There should be an auxiliary equation. Okay, row of zeros will come up only in the odd power row. So what is the odd power row you can select here? See, s power 3 you can't select because its element is fixed. Its element is fixed. You can't select the s power 3. But you can select what? You can select the s power 1 row. Correct? You can select the s power 1 row. Okay, so taking the s raised to the power 1 row again, what is the thing that you have to make it as 0? This first element. Second element is anyway 0. Take this first element, a into k plus 2. A into k plus 2 minus of k plus 1 equal to 0. A into k plus 2 minus of k plus 1 equal to 0. Right? Okay. Yes, Saurav Anand, correct answer. So, a into k plus 2 is equal to k plus 1. Now, let's say this is just one equation. Because I need the values of k and a, so I need two equations. This is just one equation right now. Okay. Now, where is the second equation coming from? After you get a row of zeros, just a second. I need to add up a slide. Just a second. After you add up a row of zeros, after you take a row of zeros, so you are now free to take auxiliary equation that is formed above the row, from the equation above the row of zeros. That is this one. A square, this one will make the auxiliary equation. A square plus k plus 1 equal to 0. A square plus k plus 1 equal to 0. Okay. The roots of auxiliary equation should be plus minus j2. I've told the system is marginally stable with the roots plus minus j2. Okay, so I'm writing here the roots is plus minus j2. Okay, so put down the roots, s equal to plus minus j omega, that is plus minus j2. So a into s square will be minus 4 plus k plus 1 equal to 0. So here you get the next equation, k plus 1 equal to 4a. Suppose this is equation number 2. Okay, so use the equation number 1 now. Use the equation number 1. What was the equation number 1? A times k plus 2 is equal to k plus 1. So a times, what is the value of k plus 1? That you will use from the equation number 2. K plus 1 is 4a. Okay, so this is equal to 4a. So what is k plus 2? K plus 1 plus 1. A into 4a plus 1 equal to 4a. Right, so you are getting, bring all the a terms on the left hand side. Okay, so you get a, 4a plus 1 minus 3 equal to 0. A into 4a, sorry, this is minus 4. 4a minus 3 equal to 0. So you get a equal to 3 by 4. You should not take a equal to 0, because if you take a equal to 0, k will become negative. Okay, k will become negative. Okay, and in the standard control system, k should not be negative. Okay, k will be negative. And suppose if you take a equal to 0, this whole will go away. A equal to 0, k plus 1 also equal to 0. Okay, and the whole second row will go away. You will not be able to form the auxiliary equation. Total auxiliary equation will be lost. Okay, so do not take a equal to 0. Do not take a equal to 0. Take a equal to 3 by 4. And if a equal to 3 by 4, that means 4a is k plus 1. Solving that, you get k equal to what? 4 into 3 by 4. 3, 3 minus 1, 2. K equal to 2, a equal to 3 by 4. Right. Option number B. 3 by 4, 0.75. K and A. K is 2, A is 0.75. Yes, got the answer. A very, very important question, and this is a simple way to solve this question. A simple way to solve this question. Okay. So that is important to learn about the questions concerned on the frequency of oscillations. And if you have got the answer, if you have understood the answer, please do hit the like button. Okay, either comment on the comment box yes or no, or hit the like button as well. This is very important. This one and even the previous case that I have explained you how to. In the previous question, I calculated the frequency of oscillation. Here, frequency of oscillation is given, and we have determined the value of some unknowns, that is K and A. Yes. Yes, dear students, it's clear to everyone. Final answers K2 and A3 by 4. Yes, it is clear or not? Just kindly comment quickly. Quickly show some energy. Yes, quickly show some energy. Yes. So some have already given the correct answers earlier. That is good. That is good. That is important that you are able to solve such questions. Yes, it's important that you are able to solve such questions. It should be solvable. It should be solvable. Okay, dear students. So what I am going to do now? I am going to take up this question. But right now, take up this question as homework. And with this question, I'll solve it tomorrow. Okay, tomorrow I am going to take this question. Just giving you as a homework. Okay, one homework is also important. It's a GATE 2022 mark, very simple question. It's a very simple question, so why you can take it as a homework. It's a very simple question of GATE 2020. What is the value of K for which the system is marginally stable? See, only marginally stable. Okay, Manish, usually, commonly 4th, 5th, but even they have asked up to, one time they have asked up to 7th order also. So we can't say. In the mains, they have asked up to 8th order also, but in GATE also, they have asked up to 7th order also. That is very rare, but they have asked. Okay. So it's a simple question homework. I'll take it tomorrow. I'll tell you the solution of this. What solution? You know, the value of K for which marginally stable. Same like the last two questions. Even they are not asking the frequency of oscillation. What is the value of K for which the system is marginally stable? That's it. Okay. And as you know, tomorrow's plan, okay, after taking this question, we move towards, after this, we move towards what topic? If you have seen the schedule, we move towards root locus. We move towards the root locus, and we have 3 classes. That is tomorrow, that is Thursday, Friday, and Saturday. Okay, as far as possible, I will try to cover all the cases of root locus. As far as possible, I'll try to cover various cases of the root locus, right? Yes, dear students. So, yes, that's it for the today's class. And tomorrow I'll tell you the answer for this. Okay. I'll tell you the answer for this. And apart from that, if you are, interested in the mains classes, tomorrow morning, as you know, Control System Engineering Services mains classes are also running up free on the GradeUp app. So tomorrow, Control System at 9 a.m. The topic that is very important, that is going to be conducted tomorrow. Okay, and that is Nyquist plot. Tomorrow, and I'm also going to continue Nyquist plot day after tomorrow. Very, very important. Nyquist plot is going to be discussed. Okay. Mohanlal, you will have to improve your percentage. You will have to improve at this stage. You will have to improve your percentage. Okay. So tomorrow Nyquist plot, and tomorrow in the CFT class of EMT, that is at 2 p.m. Okay, that is also tomorrow. I'm telling you my tomorrow's plan. CFT for EMT, and tomorrow topic is polarization. Today we finished with the Poynting vector. tomorrow is again an important topic, that is polarization of waves. Okay, dear students, and with respect to control system YouTube, I've told tomorrow we are going to start with the root locus with the homework answer as well. So stay tuned to your favorite Grade Upgate YouTube channel. Do subscribe, hit the bell icon. You will get notification automatically what is running on, and do hit the like button once before signing off. Okay, so with this, I, Rakesh Talreja, will sign off for today's class. See you tomorrow 8 p.m. on the YouTube. Bye bye, take care, and stay safe at home.